Hi and welcome back. So in the past video, we were talking about intensive and extensive properties, and hopefully, I didn't confuse you too much with talking about intensive and extensive properties. But if I did, what we're going to talk about in this video is we are actually going to maybe hopefully clarify if you might have any questions or still be a little confused as to what intensive and extensive properties are. Hopefully what we're going to do in this video is maybe clarify that a little bit. And we're also going to talk, in the last video, we talked about density. Write that down. We talked about density in the last video, and we're also going to talk about density in this video as well, as a way of clarifying questions you might have about density, as well as intensive and extensive properties. So anyway, to start off with, density is pretty much going to be how, and you can think about density in terms of, I guess, the intuitive definition of density is, I guess, how much stuff there is in a given amount of space. So if you, I think one of the things I mentioned in the last video was, I remember my chemistry teacher said when we first started on density, something like what weighs more, a ton of bricks or a ton of feathers? And of course, the answer is that they both weigh the same amount. They both weigh 1 ton. But the density is much different. You can imagine, if I had a ton of bricks, and I'll just draw, so I maybe have, I'll just draw, let's say 3 bricks. So these are, let's say that these 3 bricks that I've got, and maybe we'll say that they're really big bricks, but we'll say that for right now that these 3 bricks, they're going to equal 1 ton. And we can see that, they're going to take up some amount of space. If we were putting these bricks into a truck or if we were, I don't know, building a house out of bricks or something, we would, these bricks would take up some amount of space, or, if we were shipping them, they would take up some amount of space in a truck. But now let's think about if we were going to have a ton of feathers. If we were going to have a ton of feathers, we would need way more space. And I'll just, kind of draw a whole bunch of white on the screen. We would need, would probably fill up my entire screen if I was saying, I had this gigantic, I could say that, okay, I've got this gigantic bag, I've got this gigantic bag full of feathers, and I'll just, color it in like that. And then this bag here is also going to equal 1 ton. But it's taking up way more space. It's taking up way more space than just these 3 bricks. So therefore, pretty much what we can say is that these 3 bricks are much more dense. There's much more mass. There's much more matter packed into these 3 bricks than there is packed into a whole bunch of feathers. So the bricks are going to be more dense. Both of these collections, I guess, we've got a collection of bricks and a collection of feathers, and they both weigh the same amount. They both weigh 1 ton, but the feathers are much less dense. And you can think, in a feather, maybe you've I don't know, I guess. Pillows. Some pillows are still stuffed with feathers, I think, and you can see that, you can. If I took a pillow and squeezed it, I can squeeze a lot of the air out from in between a bunch of the feathers, and you can almost tell that a lot of this space in the reason that there's, I get that the feathers are so much less dense than the bricks is there's much more air in between all the little hair follicles on each of the feathers. But anyway. The important thing to realize is that while both of these collections weigh the same amount, they both weigh 1 ton, the feathers have much less density. There's much less stuff per each unit of volume. And if you remember from the last video, that's pretty much what we define density as. It's the amount of mass. So it's some amount of mass. And it could really be any amount of mass. And we'll talk about specifically what we're going to see most often in a chemistry course. But it could really be any amount of mass per some unit of volume. Some unit of volume. So, and you can imagine that there are a bunch of different units that we could stick in here. If we were dealing with bricks, we could say, this is kilograms per liter. I don't know, like a liter is a unit of volume. We could say, I don't know. We could say, gram per. Let me think. Maybe per 1,000 liters, or a kiloliter, I guess. That could be a unit for density. It satisfies, I guess, the requirements we have, where we say that we have to have some unit of mass, some amount of mass over some amount of volume. So both of these units, we could have kilograms per liter or grams per 1,000 liters. What we're going to find is that most often in at least this chemistry course, and I would say probably most chemistry courses, the unit that we are going to use for density is we are going to say how many grams per every milliliter. How many grams of mass are there in a certain substance per every milliliter of volume that substance takes up. And, another good thing to just refresh your memory on from the last video. Remember that we said, and I'll actually scroll up here. Remember that we said in the last video that mass and volume. Oh, there we go. So we said that mass and volume were extensive. Oh. Sorry, I'm doing something. Still not used to the new pen, I guess. So we said that mass and volume were extensive properties, which plainly put just means that it depends on the amount of stuff that we have. So, if we talk about, going back to this example where we had, a ton of bricks and a ton of feathers, we can see that, the masses for one brick, the mass for one brick is different than the mass for one feather, and the volume for a ton of bricks is different than the volume of a ton of feathers. And you can imagine that the volume of stuff that we have is directly dependent on how much stuff it is we're looking at, right? So if I had half a ton of feathers, if I had half a ton of feathers, it would be, something like that. We would only have half as much. I'll actually write that in. So that would be maybe half a ton of feathers. And so we're taking up half as much space to have that half a ton of feathers. So volume would be an extensive quantity, is directly dependent on the amount of stuff that there is. Similarly, if we had half a ton of bricks, first off, we would have half as many bricks. We would have, I guess, 1.5 bricks in this example. But they would also be taking up, so we would have half as many bricks, so our mass would be 1/2 of what it had been. So, the mass is directly dependent on how much stuff there is. The mass is going to be an extensive quality or an extensive property. And the volume as well. If we have half as many bricks, we're only looking at half of this sample. So it's half as much. And I'll write that in. So we've got half a ton of bricks. We're occupying half the volume. There's half as much mass here because we're looking at half as much stuff. So therefore, the mass and the volume are both going to be extensive properties. They are directly dependent on the amount of stuff that we're looking at. However, the density that we have, so the density, I'll write down density, is going to be an intensive property. Because if I told you, okay, if we were going to figure out, and we're dealing with bricks, and then I'll try to maybe draw something that might look a little bit like a feather, and that's going to be the best feather I'll be able to manage today. It looks more like a white centipede, I know, but so anyway, we're looking at feathers and we're looking at bricks, and we know and we're trying to figure out the density. Pretty much, it doesn't matter how much stuff that we're looking at, because remember, density is going to be, so density, D for density, is going to be equal to some amount of mass divided by some amount of volume, okay? So if we said, okay, if I say, okay, I want to figure out the density of this brick, do I have to take this entire brick and figure out what the density is? And no, I really don't. I can, say I only want to take, this much of the brick, and I figure out what the density of this part of the brick is, and it's probably a good indication as to what the density of the brick is overall. And we're getting into a little bit as assuming that the brick is a pure substance and that there aren't a whole lot of imperfections in the build, which but I don't want to get too ahead of myself right now. But essentially, hopefully you can see that if we wanted to figure out the density, of a brick, we don't have to, it's not directly dependent on how many bricks we have. Okay? Because, okay, if we said, and this is, again, it's just an example. If we were saying the density, say, that piece in blue right there, for the density of our brick, let's say, I don't know, let's say it weighed 100 grams. Let's say it weighed 100 grams, and it was occupying, I don't know. Let's say it was occupying, let's say it was occupying 100 milliliters. I'm completely making this up for example purposes. This actually isn't the density of a brick at all. But let's just say that this little blue portion of our brick, if we were to chip that off of the brick, that had a mass of 100 grams and a volume of 100 milliliters. And let's say that this little blue piece of the brick, let's say it was a quarter. Let's say it was 1/4 of the overall size of this brick. Now let me ask you, what would, if we say that is 1/4 of the overall mass of the brick, or of the overall amount of stuff that the brick encompasses, what would the mass be of the total brick? If a quarter of the brick weighed 100 grams, what would the mass of the total brick be? Well, it's going to be 4 times that, right? It's going to be 4 times 100 grams. So we could say that the mass of the total brick is going to be 400 grams. And if a quarter of the brick occupied 100 milliliters of volume, so if a quarter of the brick occupied 100 milliliters of volume, how much would this entire brick occupy? Well, it would occupy, again, it would occupy 4 times 100 milliliters. So it would occupy 400 milliliters. And hopefully you can see that these two fractions are equivalent, that they're both going to come out to, and again, this isn't exactly what, this is not what the density of a brick would be, but we could say that looking at these, both of these have a density. Both of these have a density of 1 gram per milliliter, is what we're going to say. And it didn't matter whether we looked at this tiny little portion of the brick, or if we looked at 1 whole brick, or if we looked at 10 whole bricks. The density did not matter how much stuff we were measuring, how much stuff we were looking at. And that is why density is an in property. However, the mass, so this first time we had a quarter of the brick and it had a mass of 100 grams. And then we took the mass of the entire brick and it was 4 times as large. It was 400 grams. So the mass directly depended on the amount of stuff we were measuring. And that is why it was an extensive, property. So anyway, I know I didn't deal with the feather too much in this example, but hopefully you can see just from this brick example why density is an intensive property and why mass and volume are both extensive properties. And we'll talk much more about intensive and extensive properties further along in the playlist when we start dealing with some weird units, especially when we get into dealing with energy and stuff like that. But for right now, the important thing to realize is that density is an intensive property because it does not depend on the amount of stuff that we measure. It does, we can measure a quarter of the brick, we could measure an eighth of the brick, we could measure the entire brick, we could measure 10 entire bricks. The density would not change. So anyway, thanks so much for watching, and I will hopefully that clarified some stuff for you, and hopefully I'll see you in a future video.